All right, so we're jumping into continuous random variables, and this is just a rehash from previous years. So I'm just going to go straight into an example. So the example is the heights of 80 randomly selected school students are summarised in this table here. So we've got this table, and we've sort of decided there's these bins. We've got, if you were exactly 150 centimetres, you'd be in here, less than 160. So this doesn't include 160. 160 goes in this group here. So they're all grouped up together. So the first step is it says draw a histogram from the table. So in this space you would, let's just, how am I going to do this? Let's just give ourselves some room. Okay, and I'm just going to, let's move this up a little bit just to make it easier for ourselves. I've lost everything there. So just going to move that up here so it's out of our way. So in this space here, we start with the bottom, all right? And because this is one variable, we're going to have h on the bottom, which is in centimetres, which is our heights. And we've got this first one here. We've got 150, 160, 170, 180, 190, and that gets us to the top. All right, and you'll notice here that 30 is our biggest number. So let's just do, so this is our middle one here. So 170 to 180 is 30. So let's do each block is 10, 10, 20, 30. So that's going to get us to 30. What else? Have we got another easy one? We got this last one is 10. So that'll be 10 there. Now we're just going to put, now I'm going to get rid of this here. So the graph has a little thing here just to show the scale is not quite right. We're missing a chunk. And so here, I'm running out of room. I've actually put it a little bit too far. So this is just our frequency. And we've got 30 here. This will be 20. And this will be 10. Not the best diagram. So 150 was 14, so that would be about here. Now it's going to slide me down. I might have to zoom in a bit. Oh no, there we go. So that's about 14 there. And now we've got 160, 170 is 26, so that will be just above here. Now, the biggest difference between this and discrete random variables is you sit in a bucket here. The moment you're bigger than 160, you're in the next bucket. So the idea being that there's no value that can't be in this. Now, in this spot as well, you don't, I'm not going to go, actually, just leave it there for the minute. Okay, the next bit is calculate the relative frequency of each interval. So what that means is, and relative frequency, we've actually previously called that, and let's actually move that down. We'll calculate that here. So let's just give ourselves some room. Okay, so we'll just copy this, and sorry if I'm jumping all over the place here. Okay, so can I... Okay, that should work if we can just get that out of the way, and then let's get that next bit down. So relative frequency is also called experimental probability, so relative frequency. And this is sort of like we want to know as a percentage or a decimal how often each value could happen. So what we do here is we just go 14 divided by 80, because 80 is our total number of trials here. And so we end up with 0.175, 26 over 80 is going to be 0.325, 30 over 80 equals 0.375, and then we've got our last one, which is 10 over 80 is 0.125. And so the final bit is estimate the probability that a randomly selected student is between 150 and 160 centimetres. Well, that is this value here. So our probability here, our probability in this space here would be the probability, I'm just going to zoom in so it looks a bit better in our notes, the probability that the height is between 150 and 160 centimetres tall is going to be approximately 0.175. And then our last one here is probability that it's taller than 170. So probability H is greater than equal to 170. Hang on a sec, does it just say? Now, taller, this is interesting here. So taller than 170 means we include these 30 and 10. So these two values get added together, and we're going to see this as, it's going to be approximately equal to 0.375 plus 0.125, which is approximately equal to 0.5. So there's about a 50% chance. I just want to bring you up on this bit here. This is just greater than, but here this bin is less than equal to. So this one includes the 170 value. Now, in this topic of continuous random variables, these are actually the same. We actually assume that you can't possibly get the height to equal exactly 170. So these probabilities actually match up. Now, this first section, that's all we're looking at. We're just getting used to continuous random variables.